Hi everyone, in this lecture we are going to talk about recursion basics. So many people get fear when they hear the word recursion because it's a pretty confusing technique, especially for the beginners. But we will try to explain you it in a simplified manner with the help of certain examples, and we will do a lot of problem solving on recursion as well. So let's see what is recursion. So as I said, it's a technique in computer science where a solution to a problem, depends upon solution to smaller instances of the same problem. This is something that what you need to remember. So let's say you have a problem, and that problem is a complex problem. That means it has a larger input, let's say, and you want to break this problem into maybe smaller instances of the same problem. Maybe you break this into, let's say, three sub problems of, let's say, size n by 3, n by 3, n by 3. So our idea would be to solve the sub problems and combine the answers of sub problems to get the answer for a bigger problem. So that this is something what we would be doing. And what is the meaning of smaller instances of the same problem? Let's say we want to compute some function f, then the smaller problem will also be on the same function f. Something like this. So I will try to explain you with the help of one very simple example. Let us see the most classical example that is taken to uh, teach recursion. So that is the factorial question. So let's say I want to compute a factorial of a number n. Let's say that number n is 5, and I want to compute f of n that is equal to n factorial. This is something what I want to compute. Now, although this is a easier problem, but we can break this problem recursively. We can break it into a smaller subproblem of the same type. So you know what is the property of factorial. So n factorial is nothing but it can be written as n into n minus 1 factorial. And what is n minus 1 factorial? It is nothing but f of n minus 1. So it can be written as like this. So what we have done, we have written a larger problem in terms of a smaller subproblem of the same type. Now, how do we compute it algorithmically? For example, if I want to compute 5 factorial, so this will be written as 5 into 4 factorial. This 4 factorial can be written as 4 into 3 factorial. This can be written as 3 into 2 factorial. This can be written as 2 into 1 factorial. This can be written as 1 into 0 factorial. At 0 factorial, we know we have reached a point where the problem cannot be broken down further. So such a point is known as base case. So let us see what are these terms. So at this point, we would say we have reached a case which is known as base case. That means we cannot reduce our problem further, and the base case is the case where we know the answer of the subproblem. So 0 factorial is nothing but 1. So what we will return? We will return 1 into 1, 1, and this 1 will go back here. So this would become 2 into 1, that is 2, and this 2 will go back here. So this is nothing but 3 into 2, that is equal to 6, and this 6 will go here. So 3 factorial will get replaced by 6. This would become 4 into 6, that is 24. This 24 will go here, and 5 into 24 would be 120. So when we would be dealing with recursion, we will see two directions. In one direction, we are breaking the problem and we are trying to simplifying it. So that means we are moving towards the base case, towards the base case. And another direction would be in which we are again coming back from the base case towards the main problem. So this is from top to down, and this is from down to top. So we would be doing work in two directions. First, we would be breaking and simplifying the problem, then we would be combining the solutions to form the answers of the bigger subproblems that we have left. So this is how this recursion is going to work. Now you may ask, how does it will work in the form of a program? So when we are going to write the code, we will take the help of call stack, function call stack. So I hope you remember the call stack concept. So what happens is, let's say you have a function main and it makes a call to the function hello, which further makes a function call to the, let's say, to a function hi. So what happens is, in the call stack, you will see that these functions will get stacked on the top of each other. And in the order in which they are called, and once the function hi is completed it will go off, once the function hello is completed it will go off, and once the main is completed it will also go off. So recursion actually uses the concept of call stack to store all the states of these variables that we are going to have. Okay, so it will become more clear as we go through some more examples, but for this video the concept is you understand at high level what recursion is going to do. It is going to break down your complex problems into smaller sub problems. We are going to solve those sub problems and get back our answers. Okay, so let us see another example. So for example, we want to define an operation, go to home. Let's say you are standing at some coordinate, let's say some x coordinate, and your home is at some value that is equal to, let's say, n. So you want to reach this home, and what you will do, so one is you put a loop, and you can simply do take one step every time. But another thing you can do is you will say, okay, no, I will just take one step and I will ask recursion to take me home from x plus 1 till the n. Okay, so the idea is you take one step and leave the rest of the work for the recursion. Okay, so this part can be solved recursively. Again, in this part what you would be doing, take one step, leave the rest, work for recursion, take one step, leave the rest, work for the recursion. Okay, and what would be the base case? The base case would be, if you are at the home, stop moving, you don't need to go anywhere. In the recursive case, okay, the other case in which we defined a recurrence like f of n is nothing but n into f of n minus 1, this case is known as a recursive case. So what would be a recursive case for this problem? You will take one step towards home and you will call the same function go to home from x plus 1. Okay, so if I show you in the form of a little bit of a pseudocode, so this is how the code would look like. So there is a method go home which gets the current location, and it also gets where the home is located. So you check if we have already reached the home, we will say okay, we have reached the home, and return. We don't do anything further. Otherwise what we do, we take one step and we call go home from that particular step. Okay, so this is how a recursive code would look like. So you can see we are calling the same function because we said that we are going to break down the problem in terms of a smaller sub problem. Okay, so here also we have broken down, if we need n steps to reach the home, so we have taken one step and we said okay, the remaining n minus 1 steps will be taken by the same recursive function. So this is a pseudocode, and the idea is you understand at high level what is recursion is going to do. So recursion also related with the idea of principle of mathematical induction. So you might have studied about this principle while in your school or in college. So in this principle, what we actually try to do is we first figure out the smallest case. Maybe we see what could be the smallest possible solution for the given problem. Maybe what could be the value of f of 0, maybe what could be the value of f of 1. So this will depend upon what kind of question it is. Okay, so in some cases we may have f of 0, f of 1, maybe f of 2 as well. So we want to figure out what is the value of the smallest case. For example, in case of factorial, the smallest case is 0 factorial, that is 1. Okay, in case of a Fibonacci, there would be two smallest cases, because to build Fibonacci series we need two initial values, 0 and 1. Only then we can build the next value. So this we will look at later on as well. First step is always figure out the smallest case. Then when you're writing code for the recursion, one assumption that you always need to take is, suppose you're breaking down your problem f of n in maybe two sub problems, f of, let's say, n by 3 and maybe f of 2 n by 3. So what you need to assume that sub problem can be solved. Okay, so you have to assume that these two sub problems will be solved recursively. Using this assumption, you have to write a recurrence. Okay, you have to write a recurrence for f of n. Okay, how I can combine the solutions of the smaller sub problems to get the answer for f of n. So once you do this, your code will work fine, and you can also verify and think why your code works. Okay, so you have to solve the current problem assuming the sub problem solution exists. Okay, so this is our assumption, but it will actually work, and we will prove it why it works. So we have to find out, okay, let us assume that sum f of n minus 1 is true, or using this we will find out, okay, what is f of n in terms of f of n minus 1. Okay, or n minus k or something. Okay, so it could be any sub problem, it can be broken down in any way, and it will depend upon problem to problem how we break down the problem into sub problems. So this is a high level introduction about recursion, and in the next lecture we will actually see an example along with the code. That's all for this lecture. Thank you.